Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Today I am going to explain the head to tail rule of vector addition. If we are given with two vectors, here I am taking the example of two vectors, that is F1 and F2. These are two forces. Say F1 is 150 Newton and F2 is 170 Newtons. Okay. Now, I can say that there is an angle between them. Suppose I'm taking that 50-degree angle between these two forces. Now, I just want to brief you the situation like this, that what is happening here actually. For example, this is an eraser, and we are going to apply two forces on this. One force is being applied on this direction, like 150 Newton force, and other force is being applied in this direction. Now we have to see that in which direction this eraser is going to move. One force is 170, which I am showing with the help of a red pencil, and the other force I'm trying to show with a yellow color uh, stick. So you can see that these two forces are being applied. One is dragging it in the rightward, and other is dragging in the upward direction, slightly upward direction. So under the action of these two forces, where this body will go and what will be the angle of the resultant, we have to see this. Okay. So kindly observe that what we are going to do, that we are going to discuss that the head to tail rule of the vector addition. The first thing which I told you, that you have to choose a scale. You have to choose a scale. Uh, so let me see that I am choosing that 25 Newton may be taken as 1 centimeter. I can choose this, and instead I can also choose that 20 Newton is equal to 1 centimeter can also be chosen. So if I take that 20 Newton as 1 centimeter, suppose 10 Newton to 1 centimeter can also be taken. Actually, I'm not taking 10 Newton to 1 centimeter. Otherwise, I will have to draw the line 17 centimeter long. Okay. So if you can take 30 Newton to 1 centimeter, that's also okay. 25 Newton to 1 centimeter is also okay, as you know that 150 and 170 is written. So here I am taking that 20 Newton to 1 centimeter. Okay. Now 150 divided by 20. So 150 divided by 20 gives you 7.5 centimeter line, and 170 divided by 20 gives you 8.5 centimeter line. You can check that these are the things which I have done to choose a scale. You have to choose a scale according to your convenience. Now what I have to do, I have to see that this force F1, I am taking F1 first. So I'm going to draw a line measuring 7.5 centimeter in rightward direction. So here I am going to draw first of all F1. So you can observe that F1 7.5 centimeter line. I am going to draw 7.5 centimeter. And I have to mention the length of the line also. 7.5 centimeter is the length of the line which I have drawn. As I told you that it is very important to mention the arrow to show the direction. Now here you can see that according to head to tail rule, I told you that uh, the tail of the vector is this. This is the tail. This is the tail of the vector, and this is the head of the vector. Now for the vector F2, this is the tail. This is the tail, and this is the head where B is written. This is the head. Now what we have to do, we have to join the tail of F2. We have to join the tail of F2 with the head of this vector F1. This is the vector F1 with which I am going to join the tail of this vector. It means that I am going to place this vector Suppose this vector is pencil, I'm going to place it like here. But you can see we also have to consider this angle of 50 degree. Actually, you must be very much good in geometrical construction. If I am going to draw the straight line, this angle will be 130 degree. So this is 50 degree, then the remaining angle will be 130 degree, because I have to join this line with the head of this. So I need to know this angle, basically the angle with this force. This angle is 50 degree and this remaining angle is 130 degree. So please look at here very carefully that I am using this set square to draw the angle of 130 degree. This was the angle of 50 degree. Otherwise, I have to extend this line to draw the angle of 50 degree. Instead, I am taking the angle of 130 degree, because you know that on a straight line, the total angle is 180 degree. From 180, I subtracted 50. So the remaining angle will be 130 degree. So I am going to draw the angle of 130 to join the force this. First of all, I'm going to draw the angle of 130 degree at the head of the first force, which I have already drawn. Look here. Here I am going to draw the angle of 130 degree. I have mentioned the mark of 130 degree with the help of this dot. Now, I have to draw the line of 8.5 centimeter, because 170 Newton are represented by 8.5 centimeter. Here with the help of the ruler, I am going to draw this line of 8.5 centimeter. Very carefully you have to join these lines. Now you can see that I have drawn with the help of the ruler the line measuring 8.5 centimeter. Okay, this is F2. This is F2. Now you can see that the head of the first vector F1 is joined with the tail of the second vector. Here there is angle of 130 degree. 130 degree. Instead, you can say that here, if I am extending this line like this, I am mentioning a dotted line here, a dotted horizontal line. So this will be the 50 degree angle. Please concentrate here. Okay. Then later, inshallah, I'll reply. Now, what I am going to do to find out the resultant. Now I have to find the resultant force. Our aim is to find out the resultant force, that what will be the resultant of these two forces. As in the beginning, I told you that these two forces are being applied on this eraser. Then where the eraser will go, we have to see the direction of the eraser, and we have to see the resultant of these two forces. Now, the tail of the first vector, listen to me carefully, the tail of the first vector will be joined to the head of the second vector with the help of the ruler. So I am going to join the tail of the first vector with the head of the second vector. So you can observe that here I have drawn a line. This line is the resultant. I have mentioned this resultant with R. How much is this resultant? You have to measure the length of this line with the help of the ruler. So here you can see that I found, if I am very much careful in measuring this, if my construction is very accurate, then I can say that it is almost 14.6 centimeter. This line is 14.6 centimeter. Okay. Now, this is not enough. We have to give the answer in terms of force. So what is the resultant force? Basically, as you know that initially we divided with the given scale. Now 14.6 will be multiplied by 20. By multiplying it 20, what is the answer basically? 14.6, or we can say 146 multiplied by 2. This gives you 2 6 are 12, 4 2s are 8 and 9, 2 1s are 2, 292. So the resultant will be 292 Newton. This is the resultant of the given two. With the help of this toothpick, I am showing the vector OA, and with the help of this second toothpick, I am going to show the vector OB. Now, what I am going to do, actually, separately, if I am looking at separately at this vector, so you can see that this is the tail of the vector. Let me tell you that separately, if you see, then this is the tail of the vector and this is the head of the vector. What I am going to do, I am picking this vector like this and I am putting this vector at the head of this like this, because here the head of this vector is joined with the tail of the other vector. Okay, these are joined basically. When we join these two, then we say that head to tail rule. This is basic of the head to tail rule, that we are joining the head of one vector with the tail of the other vector. Otherwise, these two vectors were lying like this. Okay, I am picking this vector and placing it here like this. I have to keep that this is angle of 50 degree. So this angle is 50 degree, as you know, that I can also draw the angle of 50 degree. If you want that I must draw the angle of 50 degree, then what I have to do, please look at here. Another question which you were asking, that what is the meaning of 292 Newton? Actually, 292 Newton is the force with which this eraser is going in this direction. Okay, 292 is the combined effects. Listen to me carefully. The 292 basically is the combined effect of these two forces. These two forces are pulling this eraser in this direction. Now let me complete this, because I also have to tell you the direction of the resultant. Now this eraser will go in this direction under the action of these two forces. And what will be the direction? Because on the page you can see the direction with the help of the arrow and this line. Now in the examination, if you are going to describe the direction, then you can measure this angle. So I am going to measure this angle with the help of protractor. I found this angle is 26 degree. This angle is 26 degree. So my complete answer will be that the resultant is basically, if I am writing, because I told you in vector you also have to mention the direction, that 292 Newton making an angle of 26 degree. Now, with which force this 26 degree is being made? With the force of F1. F1 is 150 Newton. With the force of 150 Newton. With the force of 150 Newton. Okay, making an angle of 26 degree with the force of 150 degree. Now let me do it again. Actually, now here I am doing it again by making this angle of 50 degree. Actually, there are certain students whose geometrical constructions are a little bit weak. So actually, please practice the geometrical constructions. I'm again doing this with 50 degree angle. Now, how I'm going to do with the 50 degree angle, please concentrate. Okay, so you will have to observe that to construct. First of all, I am taking the force F1, which is being made with the help of the 7.5. Now, here I am going to draw the line of measuring 7.5 centimeter. This is my F1 force, which is represented with the help of a line 7.5 centimeter. Now, here you can see that this line of 7.5 centimeter ends here. Now, if I have a protector like this, I have to place a protector at the end of this, because you must be aware that how I'm going to make the angle. Now, this angle 0, 10, 20, 30, 40, 50. This is the angle of 50 degree, because I am going to join the other force with the first force, at the angle of 50 degree. Now I have drawn the angle of 50 degree. Here you have to give a reference line with which you have drawn the angle of 50 degree. So I am extending this line with the help of a dotted line, so that it must be clear that this dotted line is not the part of my force. This dotted line is being drawn to show you the angle of 50 degree. So this dotted line is showing that this portion is not the part of my 7.5 centimeter line. This dotted line is drawn to make the angle of 50 degree, because initially you know that whenever you are setting a protector, you have to set the zero on a line. From this line you are going to measure the angle of 50 degree: 0, 10, 20, 30, 40 and 50. So I have marked this 50 degree here like this, because these two forces are joined tail to tail with 50. But according to head to tail rule, we have to bring the tail of the second vector at the head of the first vector. What I am telling you, we have to bring the tail of the second vector at the head of the first vector without changing its direction. Without changing its direction mean without changing this angle. This angle should not be changed. If this angle changes, it means your construction is wrong. So I have drawn the angle of 50 degree. Now I have to join this with the tail of the first vector with the help of 8.5 centimeter line. Now look here again very carefully, that with the help of 8.5 centimeter line, I am joining these two vectors like this. Your constructions must be as much as possible accurate. Now here you can see I have drawn 50 degree angle. So this is F1 and this is F2, which is represented by 7.5 centimeter line. Obviously this F2 was 170 Newton and this F1 was 150 Newton. Okay, so remember this. After doing this, we have to find out the resultant. As I told you, that resultant is the combined effects of both the vectors. Okay, now what is the combined effect of both the vectors? You have to draw a line which is joining the tail of the first vector, which you have taken in order that as a first vector. The tail of the first vector will be joined with the head of the last vector. So the direction of on this line will be from the starting point till the ending point, because this was the starting point and the arrow will go in the other direction, because both the vectors, the direction of both the vectors must be kept in mind. Now what is the direction in terms of angle? This must also be measured. Now again I am measuring the angle. So after measuring the angle carefully, I found that this is almost 26 degree. Again here you can see that in this construction also this is the angle of 26 degree. So how you are going to write down the resultant, the length of the resultant? First of all, you have to measure the length of this resultant, which is almost 14.6 centimeter. This is 14.6 centimeter. This is the length of the line, which is representing the resultant force, the combined effect of these two forces. Okay, so again, as I told you, that this resultant will be multiplied by the scale which you have already chosen. I have chosen the scale 20 Newton to 1 centimeter. As I told you in the beginning, you can choose any other scale. Okay, and I'll do the same sum with another selection of the scale, or I will do in other order of. Please listen to me very carefully. And so this is the resultant 292, because 14.6 multiplied by 20, 292 Newton, making an angle of 26 degree with 150 Newton force. Now look at this very carefully, that I am changing the order of these two forces. I am taking F2 first and F1 second. Now you will observe that while changing the order of these two forces, what will be the result? Now look here. this force F2 I am taking first. But remember that if I am going to draw F1 first, then I have to make an angle of 50 degree with the horizontal, okay? Or what I have to do, I have to draw the uh, first force, which is F2 force. I'm taking F2 force first. So first of all, I'm going to draw a horizontal line. Here I am taking an angle of 50 degree, and I am going to draw the, or you can otherwise, if you don't want to do it like this, just wait, because these two forces are making an angle of uh, 50 degree with each other. So I am drawing first force, which is 170 Newton, represented by 7.5 centimeter, 8.5 centimeter. So I am going to draw this line without measuring any angle, 8.5. Okay, now here you have to see that how we are going to draw a horizontal line. This is vector F2. This is vector F2, which is represented by 8.5 centimeter line. Here is the direction. Now this is the tail of vector F2, and this is the head of vector F2. Now at the head of the vector F2, I am going to place this F1. I am going to place this F1 at the top of this here, like I'm placing it over here. Okay. I have to keep in mind that its angle with this force is 50 degree. So to take the angle of 150 degree, what geometrical steps I have to take? Actually, I must draw, I may extend this line like this. There are different geometrical steps which you can take if you are very good in geometrical steps. Then whatever the way you can take, actually you must make the angle of 50 degree. Now here you can see that how I'm going to make the angle of 50 degree. I'm placing my protractor like this. Okay, like this I'm placing my protractor. Now from this zero, I'm going to measure the angle of 50 degree. So here it comes the angle of 50 degree. I'm marking this angle of 50 degree. Actually, this dotted line is showing that this dotted line is not the part of this vector 8.5 centimeter. Now as I have marked this dot, I am going to draw the line measuring 7.5, because F1 is represented by 7.5. Here you can see that this line is 7.5 centimeter. 7.5 centimeter. This is F1 basically, which is representing. Now I have joined the tail of the first vector with the head of the second vector. Again, the tail of the first vector will be joined with the head of the last vector which you have joined. Now you can draw a line to represent this resultant. Again, you may observe it very carefully. If your construction is very good, then you'll see that your answer is, again, you can see that it is again 14.6. This angle can also be taken, or you can also take this angle. Now this is the resultant, 14.6 centimeter. Now how I am going to write down the resultant? Resultant, as you know that I took 20 Newton to 1 centimeter. This 14.6 multiplied by 20. So 14.6 multiplied by 20 gives you 292 Newton force, making an angle. Making this direction is very important. Making an angle of what? Now it depends upon you that which force you are taking. In this case also, you may take F1 or F2 for the reference angle. Okay, here I can also take the angle angle with the F2. So I have to measure this angle. I am measuring the angle. Normally people take the angle from the first force which you have joined. This is 23 degree, almost 22 something. Okay, this is 22 or 23 degree, making an angle of 23 degree with which force? With F2, with F2, with F2. Okay, this is the resultant, that how you are going to mention the resultant effects of two forces. Please, you will have to watch this video again. Now